Okay, example 3 for getting lines of best fit for real-life data. In this case, we're going to look at the bald eagle pairs, and this is since 1985. And you know the bald eagles were close to extinct, and then they were just endangered, and now they're actually off the endangered list. And the recent thing I heard was that the tribes are starting to petition to see if they can legally harvest a couple of bald eagles a couple times a year to make their headdresses and use the other parts like they used to use in their olden days. So it's a great thing that our bald eagles are coming back. I get to see more and more of them every year. So back to our data. So the first thing we need to do whenever we look at real life data is graph it and see what do we have. So let's take our data and we're going to draw a scatter plot. So our time is always our independent variable if we've got time in our graph. So we're going to put time down here, and this is going to be years since 1985. So this is years since 1985. Okay, so 3 years since 1985 is actually 1988. 5 years later would be 1990. You get the idea, you just add the numbers together. And the bald eagle pairs, and pairs means there's two, because you have to have a breeding couple. So this is bald eagle pairs. So this is sets of bald eagles that live together. And we need to graph it, so we've got to figure out, we were talking about numbers 3 through 26 across my x-axis. So 5, 10, 15, 20, 25. I could probably count by fives and that would be fine. So 5, 10, 15, 20, 25. If you've got your own graph paper, you don't have to worry too much about the numbers you pick. I've got my limited graph paper here, so I've got to kind of plan out what I'm going to count by to make sure it fits on my table. Across our y-axis, we're starting at 2,500 and going up to 5,000. You probably do want to plan a little bit about where you're going to start counting and where you're going to count to. I don't really need numbers less than 2,500, so I can start my graph down there. So on my y-axis, I'm going to have a little break in my data, where on my x-axis I didn't. And if I want to go up to 5,000, so 25, 30, 35, 40, 45, 50, 55, 60, that's going to fit. So if I count by 500s, so this first set of data, let's see if I can move my bald eagle pairs off of here. So I've got room here. This is going to be 2,500, 3,000, 3,500, 4,000, 4,500, 5,000, 5,500, and 6,000. So that all fits on there. And of course, it's not going to fit all the way up to the year 26 or 26 years after 1985, but I don't need it to be on my graph. I'm going to use my equation that I'm coming out with to approximate what's going on in that year. So we need to graph our data. So it's going to be the point 3, 2,500. So let me put my points on there. 3, 2,500 is approximately there. And then I've got 5 and 3,000. 5 and 3,000. That's a nice little intersection. 7 and 3,700. 7 and 3,700 is somewhere in that area. 9 and 45,000 is up here. 11 and 5,000 is here. 14 and 58,000 is here. I probably could have spread my X's out a little bit further. But you can see that this does line up pretty nicely. And I can grab my line tool and grab and draw a line here. Oops. Don't need that one. That one can go away. I didn't mean to draw that. And then we want to line up our line and see where it fits the best. We want, points on both sides of our line. So it's kind of a good representation. That looks pretty nice. I've got some points to the right, some points to the left, and 3 points right on my line. So I've graphed my data. You can see that as the years go on and we get more and more years, our bald eagle pairs are growing. So the relationship, that one getting bigger while the other one's getting bigger, that's a positive relation. And so we would expect our slope to be a positive slope. I've drawn my scatter plot. I've drawn my line of best fit for my scatter plot. Right now we're working with linear data, so we are only dealing with lines. The next thing I want to do is write my equation in slope-intercept form. So I have to, 1, find my slope. In order to find slope, I need to find 2 points. So I want to go over to my graph and find 2 points that are on my line that I think best represent my line. And the way I drew my line, I kind of like my very first point and my very last point because my line is straight through the middle of those points. So my first point was the point 3 and 1980, well, sorry, 3 is the year, and that's 2,500. And then my other point was the very last point, so that was 14 and 5800. So I'm using this point and that point. Okay, after I've got my 2 points, part B, I actually am going to compute my slope, which is y2 minus y1 over x2 minus x1, or it's delta y over delta x, however you like to think about that. Delta is a Greek letter, and it means change in. And so when we talk about the delta y, we're talking about the change in y. And anytime you find change, you're actually doing subtraction, so that's where that came from. So filling that into my equation, I have my y2, which would be my 5,800, minus my y1, which is my 2,500, over my x2, my x that goes with my 5,800, minus my x1, which is my x that goes with my 2,500. I can do my subtraction here. So 58 minus 25, let's see, I have my 2 zeros. That would be a 3. 8 minus 5 is 3, and 5 minus 2 is 3. And then 14 minus 3 would be 11. And then since it's real life data, I usually just grab my calculator and get a decimal approximation instead of dealing with the fraction. You can leave it as a fraction if you like. I just have always tended to do it the other way. So 3,300, and a fraction line means divide by 11, and I get that is just a flat 300. So that's equal to 300, which is equal to my m, my slope. After I've got my slope, the next thing to do is to put it in point slope form. And point slope form is y minus y1 equals m times x minus x1. So I have y minus, and my y1 in this case was 2,500, and my slope is 300, and then x minus x1, and that was a 3. So I want to use my distributive property. So this is going to be y equals 2, oops, sorry, not y equals. Y minus 2,500 is equal to 300x, and then 300 times 3 is 900. And then I want to move my 2,500 to the other side, and this is getting myself into my slope-intercept form. Remember, slope-intercept form is that. So third step, headed into slope-intercept form. So add 2,500, add my 2,500, and my y is going to be equal to 300x, and that's going to be a plus. So that's 2,500 minus 900 is 1,600. So I've got my equation. Okay, so I wrote my slope-intercept form of my equation. And then we want to know, what would the bald eagle population be today? What is it today? Well, first we've got to figure out how many years since 1985. So it's the year 2012. And it is, actually, let's go take a look and see what we can find for data first before we get too carried away. So open up another slide. Let's do a quick search. Okay, so I did a quick search and I came out with this website, the U.S. Fish and Wildlife Service. It seems to be a reputable site, I would think, for knowing this kind of information. Notice that this article is June 2007, so we'll have to look up the data in 2007. And in 2007, it's saying that today, after decades of conservation effort, they are home to some 10,000 nesting pairs. So we're looking at the year 2007 and having 10,000. So we want to do an approximation with our line for the year 2007. So let me go back to our data here. So not the 2012 year. We want to find 2007. And you're going to find when you look on the internet, there's not going to be too much more data after that, because once it came off the endangered species list, they stopped tracking the actual number of pairs each year. So 2007, so our equation needs to fill that in for x, because time is our independent variable, so it's our x variable. So we got y is equal to 300 times, and this is the year since 1985, right? So we need 2007 minus 1985. So 10 minus 8 is 2. So it's going to be 22. So we want to fill a 22 in here, plus 1600. So we'll grab our calculator and go 300 times 22 plus 1600, and we get approximately 8,200 nesting pairs with our equation. And remember, when we went back to the internet, our actual data was 10,000. So we're a little bit off with our line, but we're in the right ballpark. Again, it is an approximation. So we ended up with 8,200.